Okay, we're at 7.5. Hope you had a chance to digest 7.4, looked at some of the handouts, reviewed, and tried some questions. Please try to get that done before you enter 7.5, because again, it's the assumption that you have prior knowledge when it comes to things like midpoints. What I mean is literally right here. Okay, we are going to revisit this and what that means in quadrilaterals. So again, in the previous section, we have done three-sided shapes, in other words, triangles. Now, we look at the implications of what midpoints and diagonals can do in four-sided shapes. And if you are inquisitive, or if you truly have mastered the applications and the implications of midpoints and medians, you may be able to imagine and extend your knowledge to what all midpoints and stuff might mean for five-sided or six-sided or seven-sided, so on and so forth. Okay? Without further ado, let's get started. Once again, you might want to take this time to bust out a paper and pencil, copy some notes so you don't ever have to look at this video ever again. I'm going to start off by drawing a random quadrilateral. In other words, a four-sided shape. Okay. And for the sake of being able to communicate more effectively, I'm going to corner each vertex with a letter. Okay, A, B, C, and D. If the midpoints of a quadrilateral, 1, 2, 3, 4, connect with each other, what's interesting about this is that you will always get a parallelogram. By example, here is one. Let's choose a different color that you can see nicely. Midpoint, eyeballed that. Midpoint, eyeballed that. Midpoint, eyeball that. Midpoint, eyeball that. If I were to connect, oh, I jumped the gun here. And just to revisit and review what it means to be a midpoint, this line and that line are equal. These two line segments are equal. These two line segments are equal, and these two line segments are equal. Back to the point. If going in a clockwise or counterclockwise direction, if I were to connect the midpoints of each side together, you will inevitably get a parallelogram. Always. Let me write that down once again. Okay, this is a very important part of today's lesson. If midpoints are connected in clockwise or counterclockwise direction, you will always result in a parallelogram. For the sake of shorthand, instead of having to write parallelogram every single time, I'm going to write parallelogram from now on as two parallelograms, two parallel lines plus gram afterwards. Hope you're okay with that shorthand. Okay. What's interesting about quadrilaterals is the more special the quadrilateral becomes, the more interesting things we can do with midpoints and diagonals. What do I mean by that? Let's pretend instead of a random quadrilateral, I actually give you a parallelogram to begin with. So let's try that one more time. Parallel line of equal length, parallel line, and a parallel line. Okay, it may not be perfect, but please bear with me. And here is a parallel line mark and parallel line marks. Okay. If the quadrilateral is already a parallelogram, what we observe with the diagonals, lines that connect opposite vertices, and is that the diagonals will intersect each other and effectively bisect each other perfectly in half. And that is this line and that, so from the midpoint, this line segment and the other line segment is equal. The diagonal here cut that line perfectly in half. In the same way, the line segment to the middle and the line segment to the middle, these two are equal. The other diagonal, cut that line perfectly in half. So let's make a little note. If the quadrilateral is already a parallelogram, okay, the above still applies, and that is, if I made the midpoints of this parallelogram and connected each other, I would have a parallelogram inside a parallelogram. Okay. But another thing is that's also important that I just said, but it has another special property regarding diagonals. What is that special property? The diagonals of opposite vertices will always bisect each other. And as a quick and shameless plug into our previous note, if you're not quite sure what the word bisect is, please go back to the previous section, the video that we've done. We've talked about what bisect means, okay? Essentially, these two relationships are all there is to chapter 7.5. And I keep saying this in previous videos too. It is not enough to memorize this and this relationship. The challenge is to identify how these two properties could help you in planning, designing, problem solving, so on and so forth, in situations that may not seem as obvious. How could these two things help you in otherwise impossible circumstances to answer, so more complex questions to answer? So try to apply these two pieces of information in your homework questions, okay? That's it. That's it for today. Okay? If I know 7.4 was a long video, but 7.5, this is it for your homework. I'm gonna get you to, okay, watch the other video for filling in handouts. Okay, and that is done by another colleague of mine, another fellow teacher at Northern. Please fill in your handout. Number 2, see if you can apply these two properties to your advantage by trying the textbook questions, page 405, numbers 1 to 3, 5. Oops, I should really make that easier, cleaner. Questions 1 to 3, 5, 7, and 12. Okay? Try them. If you have any questions from here or any questions from the handout itself, please refer to the instructions in how to email or drop into the office hour on Mondays, the time of which will be announced in the future. It may even change every week depending on what my circumstances may be. I hope you'll do well. Hope you'll give this a shot and keep up with the material. I will see you on Monday. Do your best and hope to see you soon. Bye.